Hey guys, so today we're going to discuss about the question called as word ladder. So this is a Leetcode hard question. It also has good amount of likes as well. So this is also an important question as well. So let's start reading the question. So given two words, begin word and end word, and a dictionary word list. So return the number of words in the shortest transformation sequence from begin word to end word, or zero if no such transformation exists. So I don't know, I know, right? I know it doesn't make sense by reading this. So let me tell you what they're trying to say. So what they're trying to say is they'll be giving you two words. One is begin word and one is, let's say, begin word, and one is like end word, right? So what they're trying to say is you have to return an integer where you have to use the given words of given list of words and make a sequence that would end up going to end word. And the way you make a sequence would be, for example, let's say from begin word you have to go to some other word. So you can only go to some other word only if these two are differed by one character. So for example, let's say in the given, let's say we have hit, right? Hit, and we have hot. So these two are differed by one character, which is I and O. So if I replace I with O or O with I, they become equal, right? So only if they differ by one character or one letter, then only we can go to that adjacent word. So based on that condition, we have to make connections between one word and another word, and we have to try to make sure we have to go to the end word, given word. So I know it doesn't make much sense, so let's try to take the given example itself and let's know how can we make a graph, and how can we find the shortest sequence to the end word. So here we are having two words. One is begin word and another is end word, and we also have a list of words which might be of different size. So first thing is all these words will be of same length. That's the case. So every word will be of same length, so we don't have to bother about what if there might be of different length. So all are equal length, so that's a good thing. So what they're trying to say is you have to find the shortest transformation sequence, right? So that's what they are asking. So for example, let's try to find the shortest transformation sequence for this example. So first thing, we have given a begin word, right? So first word would be hit, right? It would be hit. So now the next word, let's say, what are the ones which differ by one character? What are the words which differ by one character or one letter? So let's go to the first one, which is hot. So heat and hot are differed by one character only, right? Which is I and O, right? So I can go from heat to hot. I can go like that. Or else, let's see if there is any other case from hit. So from hit to hot I went. So what is any other case? Heat to hot. I don't think there is no other case, I guess, right? Because this is only one case. So now from hot, to which word can I go? Let's take dot, right? Dot, we can go to dot because they differ by one character, which is O, which is D. Because if you remove D and if I remove H, this OT will be present, right? So they will be same. So this is one length, one path. So from hot I can go to dot. From hot I can also go to lot, right? This is also differing by one character, right? So I can go to lot as well. Oh, so there are no other cases from hot, right? So now from dot, where I can go? From dot, I have done, I'm a dot, right? I can go to lot, but the thing is I have already used lot here, right? So I can't revisit the same thing again. So now from dot I can maybe go to dog. Yes, I can go to dog because they differ by one character or one letter. G, right? I can go to dog from dot. So now from lot I can go to log because they differ by one letter, which is the last one, which is L and G, right? So now from dog, from where I can go? From dog I can go to cog, right? COG. This is one path, right? So from log, where I can go? I can go to cog, but this is already a layer. I have used that, so I cannot go to any other any other word from this log. So now as we have come to the end word, which is cog, that actually means the path which we have followed before is the shortest transformation sequence. Whenever you reach an end word, that actually means up to there, that's the shortest transformation sequence. So in this case it is 5, right? It's 1, 2, 3, 4 and 5. So that actually means the shortest transformation sequence coming to cog from the hit is 5. This is like what they're trying to say. This is the actual like explanation of this input. So let's try to see technically how can we find this like how a word is different, how is a word, one character different from other word. So let's take the given hit itself. So now let's take the hit only. So now we are having a word called as hit. So let's try to find some patterns. So as we know, we only remove one character, right? We only differ by one letter. So let's assume, what if we don't know what it is there in the first character and we know what is the second and third character. So now this is one pattern. So other pattern would be H. I don't know what it is there here, and the other letter would be H star T. So the other one would be H, I and star. I don't know what it is there. So now this is one case, this is one pattern for this. So now from hit I can go to, as I said, hot, right? So let's find the patterns of hot. So this is one pattern, star O T, removing H. Now removing one O, which is H star T. Now removing T, which would be H O star. So what I can do is I can do some pre-computation by using these patterns. I can store these patterns as a key and values are these words. So for this case, let's say I have star IT, right? So I'll be storing all the words which follow this pattern. So up till now, the words which are followed are HIT and HOT as well. No, not HOT, HIT. That's it for this case. So now the other pattern is H star T, right? H star T, which is it itself. So the other pattern is H I star, which is it itself. So the other pattern is star OT, which is hot, right? So the other pattern is H star T. So H star T is already there, right? Which is H star T. So I can add this in this list only, HOT. That actually means these words differ by one character. These words if they are in the same list, that actually means they differ by one character. So that's why what I'm trying to say is I can do some pre-computation for all the words, and I can store in the map in this way. Like key will be the pattern, and the values will be a list which contains all the words which follow that particular key pattern, right? So when I'm in particular word, let's say I'm trying to find the next adjacent word which differ by one letter. So for example, in this case I'm going to say hot. So now what I'll be doing is I'll try to find all the patterns with these words. So first pattern would be star OT. So now I'll see whether any other word in the given word list follow this pattern. There is one word which is H hot, which is the current one. We can neglect that. Another one is dot, right? Dot would follow this pattern. If we replace T with star, it would be star OT, right? So I can get all the words which follow this pattern, and I can do the basic BFS traversal, right? I can take these words and just do BFS and go on like a graph traversal. I can do that, and most probably that works. So let's try to see how can we code this. So here we are having a method called as ladder length, which passes begin word, end word, and a list of words. So as we said before, we have to get the shortest transformation sequence from this begin and end word, right, by using the word list. So what I'll be doing is, as I said before, I'll be storing the patterns in the form of a key, and value will be the words which follow that pattern, right? So first things first, I'll be creating a map for that, for showing the pattern. So I'll create a hash map. So it would be a hash map which would be of key as string, and the value will be a list of strings. So it would be a map. So hash map. So now I'll iterate to the given begin word first. So it would be I is equal to 0, I is less than begin word dot length, and I plus plus. So I'll try to create pattern at the first index. So the first pattern would be star. In this case, it would be star it, right? So what I'll be doing is I'll replace the ith index with star. So let's create a pattern. So the pattern would be begin word dot substring 0 comma I plus replace with star plus begin word dot substring I plus 1. So what I'm trying to do is I'm trying to replace this ith index with star. That's it. So now I'll see if map doesn't contains key of this pattern, then add this pattern into the map with some array list so that we can store the words, right? So now I'll have added the list for the pattern. Now what I'll be doing is I'll just get that list, map dot get pattern dot add the current word, which is begin word. So now similarly I have to do for all the words in the word list, right? So I'll just iterate to the word list. So for string to each word in word list, it's word list. So now I'll just do the same thing which I've done for begin word. So for int I is equal to 0, I is less than word dot length, and I plus plus, oh shit, I plus plus. So now again find the pattern word dot substring of 0 comma I plus star plus word dot substring of I plus 1. So now I'll do the same thing. If not map dot contains key of pattern, map dot put this pattern with new array list, or and map dot get this pattern dot add into the list, which is the current word. So now I have added all the patterns with its respective words as well. So now what I'll be doing is, as I said, I'll be doing BFS traversal, right? For BFS I will be using Q. So generally we use Q for BFS, not I. So I'll be using Q, which where we store strings in it, the words, and I'll name it as Q. And now, as I said before, I don't have to visit the same word again, right? So for that, to keep track of that, I'll be using a hash set, which would store some strings where the strings which I have visited already. So it would be of name vis, which is nothing but visited, and this is going to be a hash set. So now first things first, I have to start with the begin word, right? So I'll be adding q dot add begin word, and also visit dot add begin word. So now I'll be using a variable called as level, so that the number of levels I have gone deep inside, the last level would where I have found the target or the end word is the answer. That's it. So while I'll just go down a bit so you can see that. So while q dot size is greater than 0, what I'll be doing is I'll just find the size of q. So now I'll just do size times, because this is a layer actually. So first layer will be at level 1, the second layer level 2, level 3, like that. So size minus greater than 0, I'll be taking the current string, which would be q dot poll. I'll take from the q, and I'll see if current dot equals end word. If it is equal, then I'll return the level, right? So now, or else I'll do the normal approach, which would be I'll be taking the current character and find all the patterns. So for int I is equal 0, I is less than current dot length, I plus plus, I'll just find the pattern. String pad would be current dot substring of 0 comma I plus star plus current dot substring I plus 1. So now I'll check whether any of the words in the word list follow these patterns. So how can I check that? I can use the map where I have stored all the patterns with their words, right? So I can use the given map. So map dot get this pattern words, and I can iterate through these words. String words. So what I'll be doing is I have to make sure I have not visited that word again, right? Visit before. So if visited doesn't contain, not contains that word, then I can go to that word, which is visit.add. Now I'll visit that and I'll add that to the queue as well. And similarly, this entire thing would do the basic BFS, and whenever I have found the end word, I will just return the level at that place. So now at the end, I just have to increment the level, which would be here, whenever I have done one layer, right? So now I will increment that level, and if I don't find anything at the end, I would just return 0, because if we don't find the end word itself, we will be returning just 0 at the end, right? So this is pretty much the approach, this is pretty much the solution. Let's try to run this once. Let's make sure we don't have any mistakes. Okay, we have one. Okay, this is a spelling mistake. Begin word. Okay, this is the only one mistake. Oh yeah, it worked. Let's try to submit this. Yeah, it got succeeded. So this is how you try to, this is how you find the transformation sequence or the shortest transformation sequence from the given begin and end word. So all you have done is just BFS traversal. There are many other approaches for this. One thing would be you can just see all the possible combinations by using A to Z characters, and you can just see that you have the discussions as well, you can see in that. So this is how you find the shortest transform. I felt this is the optimal solution for that, so that's why I thought of explaining this. So if you like the video, please make sure you like and subscribe. Thank you.